Okay, we have an interesting question here. Instead of asking us to find the currents like in the previous questions, they provide us with one current. They tell us the ammeter reading here is 3.5 amps, which means we know the current through that branch. It's 3.5 amps. Okay, so they didn't assign the direction, but let's assign it randomly as this way. Let's call it I3. We know I3 to be 3.5 amps. They are asking us to find I3, I1, and they ask us to find I1 and I2, and the voltage V2 here, that's unknown. That's not given. Voltage V1 is given. Okay, we proceed the same way as we have learned to work these kind of problems using Kirchhoff's rules. So I'm going to identify the pluses and minuses for each of the devices. Sorry here. So this is a minus, this is a plus. So this is a plus, this is a minus. This is a plus, this is a minus. This is a plus, this is a minus, and this is a plus, and this is a minus. Okay, and the voltage drops across each of the resistors. For R1, it's going to be R1 I1. For R3, it's R3 I3. And then for R2, it's R2 I2. We write the Kirchhoff's equations. I'm going to start with the junction rule. Okay, I'm going to switch colors. I'm going to use this junction. The incoming currents in this case are I1 and I2. And the outgoing is I3. So we write it as such. Now, the next part is going to be writing Kirchhoff's voltage rules. And we can choose loops as we want. Now, however, since we don't know V2, it might make sense to start with the loop for which we know the most quantities, the loop that has V1 in it. So I'm going to start with that one. It might save me time. So I'm going to start here and go around this way, counterclockwise. Okay, let's use color to show how we progress. So we meet the minus of V1, so we are going to have an increase in electrical potential plus V1. Then we meet the plus of R1, so we have a drop in potential R1 I1. And then we meet the plus of R3, so we have a drop in potential minus R3 I3. Now we meet the ammeter, and the ammeter, like we did in the like we have learned in lab, it should not play a role in the circuit, so we ignore it, and we are back at where we started. So this is equal to 0. Now, if we plug in the values that we know here, we have V1 that's given as 15 volts minus R1, that's 9 ohms, times I1 minus R3, that's 3 ohms, I3, that's given 3.5 amps, equal to 0. See, this is one equation with one unknown, I1. So we should be able to solve for I1 here, which is going to be 15 volts minus 3 times 3.5, that's 10.5 volts, I believe, over 9 ohms. The answer is 0.5 amps. Okay, now that we know that, if we go back to this equation, the first equation, we know I3 3.5 amps, so we can solve for I2. So it is equal to 3.5 amps minus 0.5 amps it is 3.0 amps. So we know I2 as well. Now what's left is just V2. Take this loop here. I'm going to start here, going around here, using color but green in this time. So if we start here, we meet the minus of R3. So we have an increase in electrical potential, R3, I3. And then we come here, an increase in the voltage again, but since we meet the minus of R2, so it's plus R2, I2. And then we have a drop in electrical potential because we meet the plus of V2, so it's minus V2. And then we back where we started, so that's equal to 0. That gives us V2 is equal to R3, I3 plus R2, I2. Plugging in the numbers, R3, I3, that's 3 ohms times 3.5 amps. And then R2, I2, that's 2 ohms times 3 amps. So that gives me 10.5 volts plus 6 volts, or 16.5 volts.